Okay, ladies and gentlemen, this next video is going to be on matter. Matter notes, pure substances versus mixtures. Uh-oh. Let me see if I can get this where it shows everything. Okay, so matter notes. This is what we started on Friday. Going pure substances versus mixtures. Our critique for this, the state of Texas tells us that we must classify matter as pure substances or mixtures through the investigation of their properties. We're going to investigate the properties on Tuesday, but for right now we've got to be able to define what matter is, what pure substances are, etc. Okay, so some of us may already have this, some of us this may be the first time you see it. So we know that the definition of matter is anything that has mass and takes up space. Remember, we measure mass in grams, takes up space. That's the definition of volume, which we measure in milliliters or in centimeters cubed, also known as cc's. You may have heard in the doctor's office, take 10 cc's of this medication. Okay? Remember, matter can be changed by energy. Einstein told us that E equals mc squared. Energy equals mass times the speed of light squared. Don't worry about this formula right now. In a couple of months, we'll go ahead and we'll figure this formula out and find out how he came up with that formula. Okay? So then matter is broken up into a pure substance or a mixture. A pure substance is anything that has a definite composition. Definite. We know exactly what's in it. These pure substances have a specific melting point. PT stands for point. And a specific boiling point. Also, pure substances have a specific density. We can look up this information in a book. Density, remember, equals mass divided by volume. On Tuesday, we'll look at a little Indiana Jones video and see and discover more stuff about density. Then remember, a pure substance can be broken into an element or a compound. An element is one kind of atom. This cannot be separated. Whoops. This cannot be separated physically, meaning evaporation, filtration, or chemically by exchanging electrons or sharing electrons. Examples of elements are anything found on the periodic table. Lead, aluminum, iron, neon, slap my knee on that one. Helium, any of those kind of things. Hydrogen, oxygen, those are elements. We find them on the periodic table. There is one kind of atom, which cannot be separated physically or chemically. Whereas a compound is going to be two or more elements combined. So a compound is two or more elements chemically combined. Remember, when we say chemically combined, we're talking about sharing or transferring electrons. They can be separated. chemically but not physically. The way we can remember compounds is that they have a specific formula. For example, we can write a formula for compounds. Examples of compounds is distilled water. Tap water is not a compound. Tap water is a mixture because it's made up of calcium and magnesium and many electrolytes, etc. Distilled water, the water we use in our iron so it doesn't have white stuff in it. That's H2O. Baking soda. Baking soda is NaHCO3, sodium bicarbonate. We'll learn about polyatomic ions later on, probably end of October, 1st of November. Chalk, even sidewalk chalk, calcium carbonate. Many things take the form of calcium carbonate. The white Austin rock is calcium carbonate. Tums, for heartburn relief, is calcium carbonate. And then glucose or sugar. Remember glucose from biology, C6H12O6. These are all examples of compounds. Examples of compounds. Okay? Now let's move over to mixtures. Remember to stop the video at any point that I'm going too fast. For those that write fast, I'm talking fast so that way we can get this in under 10 minutes. I try to keep all my videos between 10 and 12 minutes, no more. All right, mixtures. Mixtures have a variable composition. Where pure substances had a definite composition, mixtures have a variable composition, meaning they can be made up of anything. It varies, it changes. Mixtures are put together and separated physically, i.e., filtration, distillation, evaporation. One of my favorite science words, chromatography, where we separate out colors. Mixtures have two or more types of matter. Okay. Let's go ahead and define what filtration, distillation, and evaporation is. You see at the bottom of your notes, there's separation techniques for mixtures. Filtrations. This is when we filter or we remove solids from the liquid. You can filter bacteria from solutions. You can filter sand. You can filter all kinds of things out of liquids. Evaporation is where we remove the liquid from this and leave the solid behind. And distillation is where we work with liquids that have different boiling points. Okay? Whiskey is distilled, vinegar is distilled, water is distilled. That way we can remove the contaminants. All right, back up to mixtures. Remember, a mixture has a variable composition. It's going to be broken up into a homogeneous or homogeneous mixture and a heterogeneous mixture. Remember, homo is the prefix that means the same, hetero, different. So a homogeneous mixture is where we have particles that are evenly distributed. we're not going to be able to see parts or layers. So cannot see the parts or layers. Salt water in the ocean. Kool-Aid, sweet tea. You can't break up the parts. We'd have to filter, evaporate, or distill a homogeneous mixture to see the parts. Then homogeneous mixtures or homogeneous mixtures are called solutions. And we often don't think that solutions can be solid, liquid, or gases. Solid solutions are steel, brass, bronze, and most jewelry. Because even 24 karat gold has other metals in it, because gold is actually rather soft. Liquid is going to be Kool-Aid or sweet tea. Cokes, that's another example. Whereas gases are air, an example. So let's highlight those so we can see the difference. So a solid is going to be steel, brass, bronze, or jewelry. Liquid is going to be Kool-Aid or sweet tea. And then the gas will be air. Okay? I'm big on colors to separate things. All right, so that's a homogeneous mixture, which we call a solution. You cannot see parts or layers. Where heterogeneous is going to be the opposite. The particles are unevenly distributed. Or mixed. You can see the parts or layers. For example, a salad. Okay? Now, I can break a heterogeneous mixture into a colloid. Say that word out loud to yourself. A colloid, because I'm sure it's the first time you've heard it. Or a suspension. Colloids are particles, colloids have particles that are large enough to scatter light. This is the Tyndall, T-Y-N-D-E-L-L, the Tyndall effect. I'm sorry, I didn't mean to close that parentheses. The Tyndall effect. When particles are large enough to scatter light, we call that the Tyndall effect. The particles will separate over time, but not settle out. Examples are fog. If you ask your parents to turn on the high beam real fast for the fog, just real fast, don't keep it for a long time because the light gets scattered and it's hard to see. Ketchup. That's why ketchup is a colloid. That's why when we go to turn over the bottle, if we haven't used it in a while, and just water comes out, because that water has separated from the heavier tomatoes. Last but not least, a heterogeneous mixture can be a suspension. A suspension is where the particles settle out. The particles will settle out. For example, muddy water, Italian salad dressing. You can see all of the herbs and spices. Blood. Orange juice is another. Okay, so those are the notes on matter. There's a worksheet that goes along with this that you'll be doing on Monday. If you're not finished with it, you'll do it for homework. On Tuesday, we'll go in and we'll go over that work. And then we'll also have some classwork over it and do some stations. All right, have a nice day.